Welcome to another unit of the workbook statistics. This time I'm going to tell you a little bit about how to read the most important tables for certain distributions. So let's start with the, I would say, most common used distribution, the normal distribution. And here we actually have two tables. Let's start with the easiest version, with the version where we have to look up a probability. So, for example, you have to calculate a probability that z is smaller than 0.85. Here, I'm using z and not x, because in this case we want to indicate I'm talking about values which are already standardized, and the table we're using here is for the standard normal distribution, because that's in, I would say, almost all cases what you will find in a book. The table for the classical standard normal distribution or normal standard distribution. That's the table you get, or the distribution you use if you use standardized values. Standardized means you subtract from the original value the mean and then divide the result by the standard deviation. Well, here we have to look up a value of 0.85. And the table we use for this usually looks like this. At first glance, this might seem a little bit odd, but well, what can you do of this table? How do you actually interpret the rows and the columns here? For this, we're going to take this value and we're going to split this up in two parts. The first part is the value before the decimal point and the first value after the decimal point. So here the 0.8. This part we're going to look up in the corresponding row. So here we look up 0.8. 0.8, that's actually here. That's the middle one in the second larger part. So that's the row we're going to need. And then we're going to look up the second part of this here, which is the second decimal. Here it's 5 or 0.05. That's what we look up in the corresponding columns. So here we have 0.05, so we're using this column. So we have this column, this row, which leads us to the respective value down here of 0.8023. So that's the probability we will get for this part and therefore for the probability function here. So to recapture this normal distribution, look up the value before and directly after the decimal point in the corresponding rows, second decimal in the corresponding column. But as I said, that's only one table relevant with regard to the normal distribution. In the second table, we have the quantiles of the normal distribution, or in other words, we're going the other way around. Before we inserted a certain value, we looked up the probability. Now we're going to insert a probability and get the corresponding value. So for example here, if we say we have an error probability of 2.5%, we're going to look up the value 0.975, which we might need for, well, something like confidence intervals, for example, or a Gauss test. If we want to look this up, we usually get tables like this, maybe a little bit larger. And in this first row, we have the probability we have to check for. So here we check the column for 0.975, this column, and directly below this is the respective quantile. So if you were to construct some kind of confidence interval, you have to look this value up. Then you're going to replace the Z 0.975 in the formula with 1.96. And well, that was already everything for the normal distribution. That one here. If you work with sample data, you conduct t-tests, you need the t-distribution. Same thing for confidence intervals. Here we need a t-distribution. We need something like this. We have an error probability which matters, and we have degrees of freedom. In many cases, those degrees of freedom are directly related to the number of observations, like for example, n-1. Then if you have 8 observations, you have 7 degrees of freedom. So in the table for the t-distribution, we also find values in the row, or for the rows, values for the columns. Let's start with the column values. The column values, that's actually the last of the 2 values. So in this case, for example, 1 minus alpha, or with 2-sided confidence intervals, 1 minus alpha half, that's something like this. So here it's the 0.95. So we have to look up 0.95 in the column. And the first value, as I said, is the degrees of freedom. It's 7. So we have to look up degrees of freedom in the rows. So here we have to look up this row. So in other words, take this row, take that column. We're going to see where the 2 intersect, which is here with this value. So that's actually what we're going to replace the T7 0.95 with. That's similar to the quantiles of the normal distribution. However, here we are going to present a table for different degrees of freedom as well. Well, in this case, I had degrees of freedom from 1 to 10. The lower parts, you might find only something like 100, 200, or 500, 1000, 2000. So what to do if your degrees of freedom do not really fit what is given in the table? Well, take the nearest one, or if, for example, there's a value of 1000 and 2000, and you have 1500, you're taking the average of 1000 and 2000. But usually, if you go much lower into the table, the difference between the different statistics becomes negligible. So we do not actually have to care so much about the details. Well, there was also the t-distribution. So this already covers everything about the normal distribution, the 2 perspectives. The t-distribution. This leaves us with 2 other major distributions. The first of those 2 is the chi-squared distribution. And that's similar to be used as the t-distribution, because in this case we also have degrees of freedom as the first value, and the second value as 1 minus and then either alpha or something else. In most cases, whereas with the t-distribution, it could be alpha or 1 minus alpha or 1 minus alpha half for 1 or 2-sided tests. Most of the chi-squared tests are 1-sided tests, so we, in almost all cases, simply go with 1 minus alpha. So with 5%, here we have 1 minus alpha, 0.95. For 5 degrees freedom, this part here. Well, if we take a look at the table, this looks really familiar as compared to the one from the t-distribution. And it's actually used in exactly the same way. In a column, we're going to look up the probability, and in the row, we're looking up the degrees of freedom. So here, we're going to this row, the 5, and we're going to that column, the 0.95. And here we're going to find as a statistic 11.07. This table is a little bit larger than the one for the t-distribution, because the lower parts we, for example, need if we want to construct some kind of confidence interval, but not for the mean, but for the variance. Well, as I said, that's the second to last distribution I'm going to cover here. The last one is the f-distribution. With the f-distribution, we actually have to expand a little bit more. We have the error probability, the margin of error, and we have 2 different degrees of freedom. So in this case, as we see here, first degree of freedom, the 5, the 7, second degree of freedom, and then again 1 minus alpha. This has a distinct problem, because if we consider our normal tables, they're just 2-dimensional. Here we have 3 dimensions. So what to do? Well, usually there is one table for each relevant probability. So you will find one table for the F distribution for 0.95. You will find another table for the F distribution for 0.99. So first select the corresponding table. Here we're going to select the table for 0.95. And then we have to check the 2 degrees of freedom. In this case, it's a little bit different than one before, because the first degree of freedom, that's what you can find in the different columns. The second one in the respective rows. So if we have here 5, 7, we're going to look up first the row number 5, and then, the column number 5, and then the row number 7. Here we're going to find this statistic. If you're not really sure about this, very seldomly do you have something like 5, 7. Usually the second value is much larger. Because, for example, with a regression analysis, this is closely related to the number of observations. And you usually have more observations than with the first one, which is related in one way or another to the number of, with regression, for example, independent variables. So usually a regression has significantly less independent variables than it has observations. That's also why the table is much larger downwards and not in this direction. So usually regression analysis, variance analysis, there's less than 10 independent variables or groups, but there's a lot of observations. So that's why down here it goes up to 1,000 something. Here usually the tables stop at 10 something. Well, once you know how to use this, you covered basically all the most important tables to be used. There might be other cases where you need, for example, Poisson distributions or something else, but the 4 ones we discussed in this unit are actually the most common ones, especially if you try to solve exercises, conduct tests by hand. Well, as I said, that's everything there is. So this concludes this session. I hope you enjoyed it. I say goodbye and see you next time.